Okay, ready, set, go. Here we go. All right, so I told you guys that when you leave pre-calculus, college algebra, trigonometry, you should be able to graph anything that you see. And here's the problem. We talked about how to divide functions. We talked about in chapter 3, and you guys had a whole test on it. But what we did not talk about is what that graph looks like. And it's really, really interesting. And what I do is I like to divide mine up into 4 sections. I'm going to talk about each one of them, and we're going to use it to generate that graph. And the first piece that we talk about is a vertical asymptote. Can you guys say this word, asymptote? And I can pronounce it the other way, asymptote. You can pronounce it either way you want. Either way is correct. I say asymptote. So a vertical asymptote is a line. The graph approaches, but never touches. So it is undefined. Undefined values. And the way that we find undefined values, if you look at this, x minus 1 over x minus 2, what value would give you 0 in the denominator? Yes, take the denominator and set it equal to 0 and solve it. So with our graph, we know we're going to have this vertical asymptote at positive 2. So if I sketch a graph, 1, 2, 1, 2, I draw this vertical asymptote. The graph's going to approach that, but it's never going to touch it because you can't plug in 2 and get a value. It's undefined. So we draw that line showing that it can never have a value at 2. Okay? Before I do end behavior asymptote, I'm going to talk about x-intercept and y-intercept. Okay? The x-intercept is where it crosses the x-axis. But you really have to think through this part. When I cross the x-axis, what's my y value? Good. Let's look at our function. F of x equals x minus 1 over x minus 2. If it's equal to 0, true or false? If the top is equal to 0, then the entire expression is equal to 0. True. So in order to solve where this is equal to 0, I can simply set the numerator equal to 0. Numerator equals 0. So the numerator is x minus 1. I'll set that equal to 0, and I get x is equal to 1. So I know I have an x-intercept of positive 1. Now let's talk about the y-intercept. The y-intercept is where it crosses what? The y-axis. Where it crosses the y-axis is where x is equal to 0. X equals 0. So in order to find the y-intercept, I'm going to plug in 0 for x and solve. 0 minus 1 over 0 minus 2. What does that give you? Negative 1 over negative 2, which is 1/2. So the y-intercept is positive 1/2. We mark that. Now the most important part of the day. End behavior asymptote. End behavior is not a word that I just like to come up with. It's a really important word that we talk about, especially in calculus. And when we get to calculus, we like to talk about negative infinity and positive infinity. That would be the end behavior. Negative infinity is where the graph ends to the left, and positive infinity is where it ends to the right. And so you have these important aspects of the graph that we need to account for. Okay? Now, the way that I find out where or what it looks like, well, first of all, let's just write that. End behavior is what the graph wants to be. So for most values, it wants to look like this. But something crazy happens when it gets around the undefined values, and we'll talk about that. So it's what it wants to be. And the way that we figure it out is we just divide. So in order to figure out my end behavior asymptote, what it wants to look like, what I do is I take the top function and divide it by the bottom. So let's do x minus 2 goes into x minus 1. What do I multiply x by to get x? 1. That goes over my 1. Multiply through by 1, I get x minus 2. Subtract, and I get 1. So what does the remainder look like? Good. All right. The next things I say are really, really important for you to understand. 1 plus 1 over x minus 2 is identical to the graph x minus 1 over x minus 2. It's just writing it in an interesting way. Where is this function undefined? Positive 2. Where is this one undefined? Positive 2. Same scenario. The difference is that this function, whatever we get without the remainder at the end, that's what it wants to look like. So this graph wants to look like y equals 1, but it doesn't for a special spot on the graph. What does the graph of y equals 1 look like? Good, Danny. It's a horizontal line that passes through positive 1. So I draw that graph as my end behavior graph right there. And now we'll be able to finish this graph off. You can see that there's 4 different quadrants, right? And that's not always the case. In this one there is. It will either assume the top part of the graph or the bottom. It can't have both, otherwise it wouldn't be a function. So do you know if this graph is going to go in the bottom section or the top section? Bottom, because the x-intercept and the y-intercept are on the bottom. So you can see the graph is going to pass through there, and it's going to approach the asymptotes, but it's not going to touch them. You can see that for most of its life, so to speak, most of its domain values, it looks like the graph of y equals 1. It's like a straight line. But then as soon as it gets to this spot 2, it's undefined and something crazy happens. Now if I go to the right side, it either assumes the top or the bottom. We don't have any points over here to give us a hint, so all we can do is plug in a value. What's a value to the right that you can plug in? 4 would work. I'm going to just plug in 3 because it's the next one over. Now let's plug in 3. What's 3 minus 1? 2, and 3 minus 2, 1. And I get 2. So the point 3, 2 is on that graph. So is it going to be in the top section or the bottom section? The top. A lot of times the graphs are kitty corner from one another. You can see in this situation they are. Now, second hour had tons of questions, which was great. But I don't want to go through their questions unless you guys have them. Are there any questions at this point? Then let's try a couple more examples. If you have something that you're wondering, then you let me know, okay? Let's go to the next page. I do 4 characteristics right away. I do vertical asymptotes. I do end behavior. I do x-intercept, and I do y-intercept. So every time I make these 4 boxes, because they tell me the important characteristics. Let's do the easy one first. Vertical asymptote. Where is this graph undefined in the denominator? 4. Any questions how I got that? We move to the next one. I'm going to do x-intercepts. X-intercept is where the numerator is equal to 0. Where is 3x plus 3 equal to 0? -1. The y-intercept happens when x is equal to 0. When x is 0, what do you have? We would have 3 over -4, so -3/4. Any questions how I have any of those 3 values? Okay, then for the last one, I take the top and I divide it by the bottom for the end behavior. X minus 4 goes into 3x plus 3. What do you multiply x by to get 3x? 3. I get 3x minus 12. I'm going to subtract them. What is 3 minus -12? 15. So I have 3 plus 15 over x minus 4. So that's another way of writing the graph, or writing the function. So what does the graph want to look like? It wants to look like y equals 3. I'm going to sketch my graph. I'm going to draw my vertical asymptote at x equals 4. I'm going to draw my end behavior asymptote. 3. I'm going to plot my x-intercept. -1. I'm going to plot my y-intercept. -3/4. Now I just have to sketch the graph. For the section on the left-hand side, will the graph end up being in the top or the bottom? Bottom. Why? Yeah, because it's got to pass through those points, and it can't cross over the asymptote there, so we have that shape. Do we have any points on the right-hand side that tell us? Nope, so we got to plug a point in. What point would you like to plug in? Yeah, let's plug in 5. That would be the next point over. 3 times 5 is 15, plus 3 is 18. 5 minus 4 is 1. So if you plug in 5, you get 18, which would be way up there. So are you going to draw the graph in the top part or the bottom part? Top part. And again, it has to fall along with the asymptotes. And you can see that, again, the graph for forever, you know, all the way over to here and even further, it basically looks like a horizontal line. Horizontal line, horizontal line, horizontal line. Then it gets closer, all of a sudden something funky happens. It just kind of has a heartbeat or something, I guess. I don't know. Okay? Any questions on how we did that one? You guys got this? Okay, let's do 2 more. Let's try something harder. Vertical asymptote. 0. X-intercept. 2. Y-intercept. Y-intercept. What number do I have to plug in to determine the y-intercept? I have to plug in 0. Am I allowed to plug in 0? No, 0 is a value for which it's undefined. So there is none. There is no y-intercept because it does not cross the y-axis. It's undefined along the y-axis. End behavior. I take the top function, divide it by the bottom. 2x goes into x minus 2. What do you multiply 2x by to get x? 1/2. And you get x minus 0. We don't have anything after that. So you got x minus x is 0. What's negative 2 minus negative 0? Negative 2. So you get 1/2 minus 2 over 2x. So that's my result. So the function wants to look like that for the majority of its time. We could see that at 0 something funky happens, but it wants to look like 1/2. So y equals 1/2 is my graph for the majority of the time. Draw my graph. I have a vertical asymptote of x equals 0. That's going to be right along the y-axis. It crosses the the end behavior is 1/2. The x-intercept is positive 2. There is no y-intercept. I don't have any points on the left-hand side, but I do have a point on the right. So if we look at the right-hand side, is the graph going to be in the top or the bottom? The bottom. So you could draw it like that. A lot of times it will be kitty corner, but we got to make sure. What point could you plug in to check? Yeah, let's plug in a -1. Something over on this side. Let's plug in a -1. -1 minus 2 over 2 times -1. And we would get -3 over -2, which is positive 1.5. So I have a point right there. So is it going to be in the top or bottom? Top. That's my graph. What you think about that? Okay, let's try one that's a lot more difficult. Now, second hour had all these questions. They had, well, when could it not be like, in opposite areas? I'll just show you one. If you had 1 over x squared, where is that undefined? 0. So you have an asymptote right there. And I will tell you this. If the power in the numerator is less than the power in the denominator, then the end behavior is 0. Now, true or false? If I square a real number, it will always be positive. If I square a real number, it will always be positive. True. So you can't ever have a value in the denominator down below the x-axis. So you're going to have one that looks like that, and the other one will look like that. So there's a case where you could have, both that are above. Some people said, will it always look like a line? No. What if you had x squared over x minus 1? Well, if you divide that, how many times does x minus 1 go into x squared plus 0x plus 0. What do you multiply x by to get x squared? X, multiply through, I get x squared minus x, subtract, get 2x plus 0. What do you multiply x by to get 2x? 2. So this graph right here wants to look like x plus 2. A line with a slope of 1 that passes through positive 2. So, and then it's undefined at positive 1. So for that one, you would have, 1 region, 2 regions, 3 regions, and 4 regions. So what? Oh, I'm sorry. 0x minus negative x would be 1x, right? 1x. That wasn't the funny part, though. What are you guys laughing about? 4 regions. Oh, region. What? And they find that funny? You guys, if stuff like that was really funny, we'd be hearing Mallory every day. Every day. She'd be losing it. And that doesn't happen. Okay. You guys have seen enough, and you're not quite as interested as second hour was, so that's okay. We'll just put it behind us. All right, so you guys take me through it. How many boxes do I make? 4. What's the first box? What does it stand for? Vertical asymptote. What's the second box? End behavior. What's the third box? X-intercept. Fourth one? Why? I make them. I find them. In order to find the vertical asymptote, I look where the denominator is equal to, which would be, or x equals 1, x equals negative 1. Uh-oh, I've got 2 end behaviors. All right, how do I find the x-intercept? I look where the numerator is equal to 0, which would be, and for the y-intercept, I plug 0 in for x. I would get 0 over negative 1, which is, so it looks like it passes through the origin. And we said for the end behavior, if the top exponent is less than the bottom, then y equals 0 is always the end behavior. Now watch, you got to be careful with this. You have to be very careful. Negative 1, positive 1. Now, I know that I have end behavior, or I'm sorry, I have vertical asymptotes. The function would be undefined passing through that. So I'm going to draw that one. I made kitchen cabinets this weekend, but you guys didn't even ask me how my weekend was. Oh, it's all right. You don't care. Then the end behavior is y equals 0. Now, is this area out here, is this kind of its end? Yeah. So I have, is the area in the middle here, is that the end of the graph? No. The area out here is the end. How about the area out here? Is that the end? Yeah. So you can see my end behavior asymptote, it doesn't cover the middle, it just covers the sides. So we have 1, 2, 3, 4, 5 regions that the graph could possibly be. We've got to try to decide what's what. What's the point that it passes through? 0, 0, the origin. That's all we know. So all we can do is really test points. What's a point to the left of negative 1 that we could test? Negative 2. 4 times negative 2 is negative 8. Negative 2 squared is 4, minus 1 is 3. Negative 8/3. So it could be in the top or the bottom? Bottom. Good. Let's go over to the other side on the right. What's a point to the right of positive 1 I could plug in? I could plug in 2. And if I plug in 2, I get positive 8 over 3. So it could be in the top or the bottom. Top. Now the question is, what happens in the middle? Take out your calculator. Take out your calculator. Take out your calculator. You guys love my picture of Meteora, don't you? Okay, so I'm going to type in 4x divided by parentheses x squared minus 1 parentheses. So that's my graph. And I'm not going to look at it in a standard viewing window because a lot of times rational functions don't show up so well. So for my window, I'm going to go to -5, +5, -5, +5. And that's what I have. Okay? Now, don't press graph yet. We're going to go to our table. And we're going to try to generate some values here, people. Okay? I want to know what happens between -1 and +1. What's a number really close to -1 that we could plug in? 0.99. Negative. Whoa. So is that above the x-axis or below it? It's above. Let's try like -0.8. Above or below? Above, but smaller, right? We go like -0.5, -0.2, -0.1. You can see that you're getting smaller. So it starts really big and it's getting smaller, but it's always positive. So we know this. The graph is very positive, and it comes to that point. And does it bounce back up, or does it pass through? We don't know. We've got to check. So what's a point that's very close? Oh, my smartboard's not working now. What's a point that's really close to +1 that you could plug in? 0.9. So plug in 0.9, what do you get? Yeah, if you plug in 0.9, you get a negative value. So you can see it's headed down. So sure enough, this graph passes through there. And if we then go to our calculator and we actually check out the graph, you can tell, hey, we get exactly that, don't we? We're pretty smart. And if you want to look at it in a standard viewing window, check it out. There it is. You got it. This assignment, I'm supposed to cover this material during the course of this quarter, which I did. But this assignment will go on to your first grade for your third quarter. So here's your assignment. We keep plugging away in this class. Where did I write it down? No,